Well, welcome back for another exciting night. Our topic today is going to cover even and odd functions. So go ahead and title that in your notebook. So let's dive in with the definition of an even function. Alright, so let's make sure again that we have all of these neatly written out. A function is even if, so here's the rule we need to know. F of negative x equals f of x. Okay, so you can expect to see that on a bunch of your quizzes. F of negative x equals f of x. And again, let's write this out. This means when I replace x with negative x, I get the original f of x out. Okay, and that's what this is saying. We're going to substitute negative x into our function, and we want to get out the original f of x. An even function is symmetric to the y-axis. Likewise, we need to talk about odd functions. A function is odd if f of negative x equals negative f of x. Do you see how similar this rule is to even function? Go ahead and take a look at your even function. Do you notice they start the same? F of negative x and even started the same way. The difference is what you get out. If you got the original f of x out, you are even. If you got a negative f of x out, you're called odd. So what does this mean? So again, this means when I replace x with negative x, I get the complete opposite of f of x. And let's go ahead and star this. Every term has to change signs. That's what negative f of x mean. It makes every value there negative. Everybody changes signs. An odd function is symmetric to the origin. One maybe easy way to remember that is that O for origin and O for odd. An odd function is symmetric to the origin. Okay, now that we have the rules written out, let's go ahead and apply them. Algebraically, determine if the function is even, odd, or neither. So you don't have to be even or odd. You don't have to have any symmetry, basically. So if a function is even, so let's just remind ourselves of the rule. We're going to take f of negative x, and we want to get out the original f of x. If our function's odd, we're going to start it the same way, f of negative x, but this time we want the negative f of x out. So all we're going to do, as you can easily see, is that we're going to substitute negative x in, and then we'll determine by our answer if we're even, odd, or if we don't have either of those, we're neither. So example 1. Okay, determine if you're even, odd, or neither. So the rule says substitute in negative x. So literally every place you see an x, you're substituting in negative x. Make sure you wrap that puppy up in parentheses. Exponents go outside. Okay, so I substitute negative f of x in, or negative x in, and now I'm just going to see what I get. So I am getting, let's see, if I raise a negative to the fourth power, that means I have a negative times a negative times a negative times a negative, and those all turn into positive, so it's positive 3x to the fourth. If I square a negative, that means two negatives, and two negatives make a positive. So this becomes a positive 5x, or positive x squared times the negative 5 plus 17. Now all you do is you compare that to the original function. Did you get out the original f of x? Does that look the exact same? 3x to the fourth, negative 5x squared, positive 17. If it looks the exact same, we're going to make a note that this is an even function. Okay, so what does that mean? Well, remember, even means you are symmetric to the y-axis. All right, so this is the algebraic test you apply, and then you just see what you get for an answer. Let's try another one. Number 2. F of x equals 12x to the 7th plus 6x cubed minus 2x. So again, I'm always going to substitute in negative x and just see what happens. Okay, remember in parentheses, exponents on the outside. Okay, so let's just clean this bear up and see what we get. Now, if I raise a negative to the 7th power, if I have an odd number of negatives, that's going to come out as a negative 12x to the 7th. If I cube it, again, it's odd, so it's going to come out as a negative 6x cubed. And negative 2 times negative x makes a positive 2x. Okay, so all you have to do now is see what you got out. Did you get the original f of x out? So go ahead and compare it. 12x to the 7th, negative 12x to the 7th. Well, right off the bat, it's not the same, so I know it's not even. Now let's test to see if it's odd. Let's see if every term changed signs. Positive to a negative, positive to a negative, and negative to a positive. Notice how every term changed signs, so this is symmetric to the origin, and the origin tells me it's an odd function. Remember, those O's go together. It's an odd function symmetric to the origin. All right, let's try another. I'm going to substitute in negative x, hopefully you've got the idea by now, in parentheses. And again, I just need to see what I get out of it. Do I get the exact same, the complete opposite, or a mixture? Okay, so if I square negative x, I'm going to get x squared. This should get me a negative 2x plus 2. So let's go ahead and compare. X squared, that stayed. Positive 2x, oh wait, I got a negative 2x. Okay, well, it's not the exact same, and it's not the complete opposite because this guy stayed positive. So I would say this has no symmetry. Okay, so it's not even and it's not odd, it's just neither. And a lot of functions don't have symmetry. All right, we got one last one to test. F of negative x equals 4 times negative x cubed minus 7. Clean this bear up. If I made it to an odd power, remember that's going to stay negative, so negative 4x cubed minus 7. Okay, let's take a look. 4x cubed, now it's negative 4x cubed, so maybe it's going to be odd. Let's check the last term. Negative 7, negative 7. So this changed, but this didn't. So again, there is no symmetry. Either everybody stays the same, everybody changes, or it's nothing. Okay, so now let's look at a graphical approach. So half of the graph of f of x is shown below. Sketch the other half based on the type of function. So they're going to tell us that this is an even function. Okay, so remember, there's a couple things we need to know about even. First, we need to know the rule. So f of negative x, we always substitute that in, and if it's even, we get the original f of x out. And we need to know it's symmetric to the y-axis. Okay, so this is pretty simple. Basically, we're just going to take our points and we're going to apply the rule to them. So let's start with this point here, the origin, 0, 0. And we'll just write them all out. We've got the point up here, 1, 2. And then 1, 2, 3, negative 2. And let's see, 4, 3. And then 5, 2. Okay, so just go ahead and list your points out. Now we're going to apply the rule and we'll write out our new points. So the rule says, when you substitute in negative x, you need to get out the original f of x. So remember, f of x is the y value. So when I substitute, well, 0, 0 is going to remain 0, 0, of course. So let's start with 1, 2. When I substitute in a negative x, so a negative 1, I need to get out the original y value. So I'm going to get out a y value of 2. We'll take the next point, 3, negative 2. When I substitute in a negative x, so I'm going to make the x negative, I have to get out the original y value. So I'm going to get a y value of 2. Oh shoot, that was negative 2, I apologize. Next point, 4, 3. When I substitute in a negative x, so I'm going to make the x negative, I have to get out the original y value, which is 3. And when I substitute in a negative x here, that'll be a negative 5. I need the original x value of, or y value of 2. So now I'm just going to go ahead and plot those. So I have 0, 0, negative 1, 2, negative 3, negative 2, negative 4, 3, and negative 5, 2. And then we'll go ahead and connect those. And there you have it. We have finished the even function. Now it should make sense because you should be symmetric to the y-axis. And again, that just means all the y values should remain the same and the x's became negative. Let's try another similar example, except this time the function is odd. So in my head I'm saying two things, and let's write them down. That means f of negative x, when I substitute in negative x, this time I want to get out the negative y value, negative f of x. And I should know odd is O, so it's symmetric to the origin. So let's do the same thing. Let's list out the points of f of x. So starting at the origin, I have 0, 0. That's 2, 4. And 1, 2, 3, 4, negative 4. 2, 3, 4, 5, 6, negative 1. Okay, now all we're going to do is apply the rule like we just said. So I'm going to substitute in a negative x. Well, 0, 0 is going to stay the same. All right, so let's start with the point 2, 4. We'll substitute in a negative x, so I'm going to make it a negative 2. And I'm going to get out a negative y value. So if my y value was 4, I'm now going to get negative 4 if I'm odd. Okay, so I'm going to substitute in a negative x on the next point, and I want to get out a negative y value. So I'm going to get out a positive 4. And then I'm going to substitute in a negative 6, and I should get out, if I'm odd, a positive 1. And then we'll go ahead and plot those points. So hopefully your graph matched mine, and we have odd symmetry. And remember, that's a reflection over the origin. Another way to think about origin symmetry is if you take your paper or your notebook and you flip it upside down, it should look the exact same as the original when it's right side up. Just another check to see if it's symmetric to the origin. Alright, so we're going to do something similar, but without a graph. We're going to be given a table. So it says, given the partially filled out table for f of x, fill out the rest. So I've got two tables there, an even and an odd one. So pause it, get those nicely copied in your notebook, and then turn it back on when you're ready to talk about how to do it. Okay, pause it and make sure you're ready to go. Alright, so the first rule says even. So I'm going to write my rule down. F of negative x has to equal the original f of x. Okay, so let's see. I'm going to start with 4 here. F of 4 is equal to negative 2. So when I substitute a negative 4 in, remember I want the original y value out. So when I substitute in negative 4, I should get an answer of negative 2. Okay. If f of 3 is equal to negative 4, when I substitute in f of negative 3, I should get the original out, so I should get a negative 4. If f of 2 equals 5, when I substitute in negative 2, I should get the original f of x out, which is 5. Okay, so now think about this. This time they gave me f of negative 1. What do you think f of 1 would be? Well, remember, I should get the same y value when I substitute that negative x in. So I'm going to say my y value should be negative 3. And how can you check to see if you're right? Well, of course, you could plot them and see if you're symmetric to the y-axis. So I have 0, 1, 1, negative 3, negative 1, negative 3, 2, 5, negative 2, 5. And you can see that it's going to be symmetric. So odd's going to be similar. So again, I'm going to start with that rule and say f of negative x equals negative f of x. Okay, so when I substitute in the negative x, I want to get out the negative y version. Okay, so let me start with 4. If I substitute in negative 4, I don't want to get the original 1 out. I want to get the negative f of x out. So I'm going to get negative 1. I'm going to go to 2. When I substitute in f of negative 2, I don't want the original 3 out. That would be even. I want negative 3 out. Okay, so now I'm going to go backwards. If I have negative 1, if f of negative 1 is negative 5, and I substitute 1 in, what should I get out? The original or the negative version? Well, we know it's the negative version, so I actually get out a positive 5. And for 3, if f of negative 3 is negative 4, I want the negative y value, so I'm going to get out a positive 4. And again, if you're not 100% sure, you could quickly make a sketch and see if it looks symmetric to the origin. 0, 0, 1 is at positive 5, and negative 1 is at negative 5. 2 is at 3, and negative 2 is at negative 3. 3 is at 4, and negative 3 is at negative 4. And you can see if you take that picture and flip it upside down, you'll get your symmetry to the origin. It'll look the exact same upside down. Alright, So what if f of x is an even function and f of 7 is negative 2? Then what is the value of 5f of 7 minus 4f of negative 7? So to me, the whole key is that they tell you it's even. So I'm going to say f of negative x equals f of x. When I substitute in a negative x, I should get out the original y value. All right, so I'm going to have 5 times f of 7, and I know f of 7 is equal to negative 2, so I can substitute that in, minus 4 times f of negative 7. Well, that's the value they didn't tell me, but I can figure it out because the function's even. So the rule says, if you substitute in a negative, you should get the original out. So f of negative 7 is also equal to negative 2. And I'll clean that up, and I'm going to say negative 10 plus 8 equals negative 2. All right, if that went too fast for you, pause it, go back, rewind it, and try it again. Let's try one more. If f of x is an odd function this time, so I'm going to highlight that and go write my rule. F of negative x equals negative f of x. And f of 7 equals negative 2. Now what is the value of 5 times f of 7 minus 4 times f of negative 7? So I'm going to say that's 5 times, well, f of 7 is negative 2, minus 4 times, what am I going to put here if I want f of negative 7 and the function is odd? Well, remember, when I substitute in negative x, I want to get out negative y this time. So I'm actually going to get out a positive 2 if I negate that. So now I'll have negative 10 minus 8 for a total of negative 18. Well, that covers our section on even and odd. So just to kind of recap, what do you have to get out of tonight? If the function is even, we need to know f of negative x equals f of x. And even is symmetric to the y-axis. Okay, so maybe make a little summary for yourself. The other big rule is if you're odd, then I start the same way, f of negative x, but this time I get out negative f of x. And I need to know that that's symmetric to the origin. And we said one easy way to remember is that those O words go together, odd and origin. Well, that does it for us tonight. We look forward to some good practice tomorrow. Have a good night.